Hi, folks. Welcome to another episode of Building SaaS on AWS. My name's Derek. I am a developer advocate, and I'm joined today by D'Amica and Nick to talk about API gateway throttling in a SaaS multi-tenant environment. Now, you might be asking, what are we doing here? What is this show all about? So if you haven't seen the show before, Building SaaS on AWS is all about helping you to understand best practices, patterns, and processes that you can implement to delight the users of your SaaS product if you're building a SaaS product. So we have a whole bunch of past episodes. I'll push up the link in a second. But we'll start this episode by letting D'Amica and Nick introduce themselves. So D'Amica, do you want to go first and introduce yourself?
Yo, thanks, Derek. Great to be in the show, first of all. And my name is D'Amica Sriananda. I'm a senior partner solution architect here at AWS. And I'm a part of this global team called AWS SaaS Factory. So my team helps with the AWS partners and customers in their SaaS transformation journeys on AWS. So apart from the technical architects like myself, we also have the business leads in the team. So together we help them to build the solution and go to market faster. So I primarily have been working with the technology partners across APJ, helping them to build their multi-tenant solutions with AWS managed services and whatever the best practices they want to have implemented. Yeah, so I'm based out of Singapore and super excited to be in the show.
Awesome. Welcome, D'Amica. And Nick, would you like to introduce yourself as well?
Awesome, thanks. Hello, everyone. My name's Nick Choi. I am based out of New Zealand, and my role is Senior Solutions Architect, and I work with our software and SaaS customers, helping them build locally and expand and market globally. All my career, I've worked in SaaS companies. Now I work with SaaS companies as customers, so you might call me SaaS lifer. I love SaaS. I think it's the best way to scale any business these days.
SaaS for life. Yeah.
That's right. Yeah. And yeah, really excited to talk to you about this fairness in API with multi-tenancy platforms.
Awesome. So welcome, gentlemen. So for people watching, we are live, so we do love your questions in the chat. So don't be afraid to ask questions as we work through this problem statement and what we're trying to solve here. And really, the first thing that we want to ask everybody is: so why should we care about this problem? What is the business problem that we're trying to solve when we talk about throttling API gateway?
Yeah, so I might take that one. So there's couple of different perspectives to the problem statement. I'll start with business side. So often with SaaS platforms, there is a business strategy to offer differentiated offering for your customers. So we're so used to seeing all these services that go from freemium to like basic tier, business tier, premium, or enterprise. All of these different tiering for your customers. Really offering these different levels of experience. Sometimes it's about feature sets, sometimes it's about the volume and performance of your platform. So just really around that differentiated offering. And as soon as you introduce that as a business strategy, of course, you need to then care about quality of service for your tenants. So how do you make sure that premium tenants are getting how you define premium experience to be versus tenants that are basic. So this also then leads into pricing impact of your SaaS platform. So there's like first is really on that business angle, and the other thing is of course operational reliability and availability of your service and experience across your tenants. And one way to kind of think about that from AWS is with well-architected framework. So that's his best practices from many of working with thousands of customers. And we do have a SaaS lens on well-architected framework, which includes 14 questions. Out of 14, 3 of those questions actually related to fairness. This is all around reliability and performance efficiency. So this we know from the customers is very important, and it's a common problem that we're all trying to solve. So one is business and second is operational. And I like to show you a diagram of what a noisy neighbor looks like, which is usually a byproduct or the impact of not having these strategies in place. So if you look at this diagram, you will see the bar charts representing tenant 1, 2, and 3, and number of requests, so representing the volume and consumption of your SaaS platform, and then line chart showing the latency or the performance experienced by these tenants. So what I've done here in the example is what you can see in purple. So this is what we might call noisy neighbor, who has very drastically increased their consumption of your platform. But if you look at the line chart, which represents latency, all 3 tenants have that degraded or increased latency in experience. So, it's all about that one user of the system or one tenant of the system putting in a load that actually adversely impacting other tenants. It could be all your other tenants, or it could be a subset of those tenants. So it's really about fundamentally, how do you limit one tenant's consumption to not adversely affect other tenants?
I almost sometimes when people say noisy neighbor, I think naughty neighbor. But we have a quick question from Sean. Are we going to talk today about the 29-second request limit, or are we going to leave that for another day?
We might leave that for another day. Obviously, that is a API gateway specific service quota or limit that we have in place today. So yeah, we might just leave that for another day.
Cool. Or as JW01 says, you can run async and not have synchronous request waiting. That's nice. Yeah. Okay, sorry, I interrupted. Nick, back to you.
Yeah, and then once you have this sort of data points, it's really about then making data-driven decisions. SaaS fundamentally is one growth business model, but also it's really making those data-driven decisions. So using metrics to understand your tenants' behavior. Our behaviors change all the time, how we use the system. So it's not something that you do it once and forget about it. So it's something that you want to continuously monitor and improve.
Awesome. So do we have, so that's the theory behind it in setting the scene, but do you have any real life customer examples, Damika?
Yeah, certainly. So one of the customers that I recently worked with in APJ is a fintech company who was actually building a fraud detection service for insurance companies. So the business model is that they have this great business logic that will kind of validate the insurance claims to identify the bad actors and the misuses of the insurance policies, etc. So this particular company wanted to kind of build a SaaS side of that and have a B2B integration with the insurance companies, which are going to be their tenants through the APIs. So the API management and having a proper control within the APIs would be one of the main concerns in this solution. And one of the questions that we discussed in the early stage in the design was, how do you make sure that we provide the fairness really across the tenants? For example, the last thing we want is having 2 big tenants coming in during the peak time and end up having 80% of the system used. So remaining 18 tenants coming in, they don't have the SLA that we promise that they will have, right? So how do you prevent that kind of noisy neighbor behaviors in the SaaS solution? So that's one of the use cases that I encountered. So we kind of compiled the same solution that they went live with. And one of the enterprises that I'm helping to build their kind of e-commerce as platform as a SaaS solution right now, they wanted to build a thorough observability platform as a part of the control plane of the SaaS solution. So they want to know what are the tenants doing at runtime, who are the tenants using what kind of load, and things like average API request count per month, average response time for selected major microservices. So these kind of metrics are heavily business valued in this particular use case. And also, we recently started a new engagement with a bank apart from having the client-side applications like web apps, mobile apps, they also providing the APIs to third-party companies to kind of deal with the same business logic. So in this use case, managing the APIs and having the consistency is one of the biggest challenges that they were facing. So in all these use cases, we kind of compile the similar solution that we're going to discuss today. These are some of the use cases, I would say.
Awesome. I'm a little bit distracted because there's a great chat going on between Code with Sean and JW1 on the chat. So how do we solve problems like this? What solutions do we propose at AWS, if any, Damika?
Yeah, so we certainly need a kind of a component at the front of the SaaS solution to handle the not only the APIs properly, but also have some control to the noisy neighbors and providing the initial construct for the API metering mechanism, right? So we certainly leverage Amazon API Gateway, which is our managed service that we can use with APIs at scale. And we are going to leverage some of the internal, like the native API gateway constructs to build something like API throttling and API quotas features. So we are going to implement the throttling and the quotas tenant-wise. So we have the control of managing the noisy neighbors, and also it will be a great solution to kind of extend to have a API metering mechanism as well. So leveraging API gateway and implementing the API throttling and the API quotas would be the solution that we are going to kind of propose in here.
Yep, cool. And I think I've got some links to those solutions as well. Let me just share those links now. So what about... I'm hearing a little bit of feedback. So what about, Damika, some of the core features in API Gateway that would help in using these solutions that I'll put the links up to now?
Yeah, absolutely. So when you look at the API Gateway, there are two main features that we can actually that we need to primarily consider to implement the API throttling and the quotas that we discussed. So let me see if I can put my screen on a little bit just to go through. Yeah, just to go through these features so that we have a better understanding before going for the design.
That's my fault for multitasking badly. Sorry, Damika.
That's not a problem. Thanks, Derek. All right, so I have just created like a simple the API for the demo purpose. It's just nothing much, but just a simple API, and we have the root API, get HTTP method, and we can actually get the pets out of this API. But I'm not going to dive deep in here. This is the pretty generic stuff, managing the API part. But if you scroll down, there are two links called usage plan and the API keys. So this is where kind of I want to focus a little more today. So the API keys is nothing but a key value pair that we can create uniquely within API Gateway. So I have created one for us to go through. So it has a name and the value. So value can be auto-generated, which I have asked the API Gateway to do for me. So the name I have used the tenant_1. So essentially, I'm going to use API key per tenant in this model, and I'm going to represent the tenants using this API key. So the API Gateway will use it as the identifier when the requests are coming in from the different tenants to identify which tenant that the requests are coming from. So the API key is actually going to be mapped to the different tenants that we are going to have in the solution. So the other construct that we are going to use is the usage plans. So usage plans helps to meter the API usage. So if I go and try to create a usage plan here, as you can see, there are two sections here, throttling and the quotas. So throttling defines the maximum number of requests per second that the client side can send to the API Gateway, and it has two parameters, the rate and the burst. So we want to know that this throttling implementation in API Gateway is actually implemented using the token bucket algorithm internally. So think of the fact that you have a kind of a bucket with a fixed size, which actually we call the burst here, the maximum capacity of the token bucket. So what API Gateway would do is it will start filling the bucket when the requests are reaching the API gateway. So the maximum bucket size will define the maximum concurrency that API gateway can handle, and anything beyond that will be throttled out. And the rate would be the actual rate that the that API gateway will fill the bucket with the request. So with the rate and the burst, you can actually implement a mechanism at the tenant level, so that you control the throttling of each and every tenant or the tenant users who are actually interacting with the solution. Now, one thing to remember is that there are default values. If you haven't done anything in this section in your API gateway, API gateway will use a bucket with 5,000 burst, and with that it can support 10,000 requests per second by default. So this is one of the most important things to remember. These configurations, 5,000 burst, 10,000 requests per second, that is an account level throttling configuration across all the APIs that you have in that particular account. That is any of the REST APIs, HTTP APIs, and WebSockets, and across all the APIs. Nice. The good news is, yes, you can actually send a request to the service team and increase the values based on your requirement. But at a given time, you will have the rate and the burst values fixed, for your account, right? So in this case, what we need to do is, when you have a multi-tenant SaaS solution using this feature, you want to make sure how carefully and efficiently you are using the rates and the burst values across different tenants. So that is about throttling. And the quota is pretty straightforward. It is how much of API calls that you kind of allow the customers or the applications to use per month, per week, or per the daily basis. So what we are going to do in our design is, we are going to kind of customize these configurations based on the tiers that we have in the SaaS solution. So remember, the API keys were mapping to the different tenants, and here usage plans are actually mapping to the tiering structure of the SaaS solution. If you have tier 1, 2, 3, silver, gold, platinum, you kind of need different configurations to kind of map. And also, when you create the API keys, you're going to map the API keys to the usage plan. So API gateway will know for a given tenant what is the right usage plan to execute. So these are the two main constructs that we need to know about API gateway to implement this.
There's a quick question from Barfight. So if you exceed burst, what happens? Does it fail silently, or does it start serving out a particular error message?
So if that happens, there will be a client side, the server will, API gateway will send a HTTP error back to the client side. You need to kind of handle that from the client side to support that.
Nice, thanks. So that's all the features of API Gateway, Dimika. What about how to implement that API throttling as part of a larger architecture that involves API Gateway? How would you go about doing that?
Yeah, sure. So one of the first things that we need to do is to make sure that we have identified the tiering structure of your SaaS solution. So let me see if I can share my deck over here. All right. So what you can see over here is some of the design considerations you want to go through before kind of implementing this. So you generally have your tiering structure of your SaaS solution, and you need to make sure that the throttling and the quota configurations are actually aligned based on the importance of the tenants in each and every tier. So in my case, I have free tier, basic tier, and the platinum tier over here. And I know that the platinum tier tenants are the premium customers in my solution who are using most of my features and paying the most for me in terms of revenue as well. So I'm going to have a higher values of throttling and the quotas for them. That makes sense. And when you go down towards the tiering hierarchy, the numbers are going to less comparatively. And I have 3 tenants allocated each and every tier. I'm going to have a dedicated API key for each and every tenant as well. Now, once you've got this setup done, generally what happens is when you're building a SaaS solution and going live, the SaaS admin will go ahead and create the 3 usage plans read to 3 tiers in the API gateway. And so one-off thing, you don't have to create that again, but you can change these numbers for the throttling and the quota values going forward based on the API usage of the tenants as and when. So generally what happens is you go with some numbers with your with whatever the gut feeling, and then let the system run a few weeks or 1 month, and then come back and change the numbers accordingly. So once that setup is done, we need to create the new API keys when the tenants are kind of onboarding. So we're gonna kind of disrupt the onboarding flow of the tenant in order to do that. So generally, what happens is in a SaaS solution, you have a landing page which is public, and we have the different tier definitions there, so anyone can come in and sign up. So I have a tenant registration microservice to accept those registration requests internally in this example. So one of the first things that we need to do during the tenant onboarding part is to create the new API key for the new tenant, right? So I got a new platinum tenant coming in over here. I go ahead and create a new API key. So from this microservice using the API Gateway SDK, I connect to the API Gateway and create that. And also, you need to map this new API key to the platinum usage plan that the admin has already created. So that is the configuration to be done in the API Gateway as well. And the final step would be to save the mapping in the database between the tenant ID and the API key, because we are going to use that in the next step. So ultimately, you will have a table like this with the tenant ID and the API key mapping within your SaaS solution. I have used a tenant management microservice for that. So once you have this mapping for all the tenants, you need to present this API key to the API Gateway so that it will know how to track or identify the different tenants based on the APIs and track it, right? So the one way of doing that is leverage the Lambda authorizer. Lambda authorizer is a standalone Lambda function that can be plugged into the API Gateway. So API Gateway will call it when there's a request coming in. So here I have the client application and downstream microservices and API Gateway in the middle. So when there is a user who, from a tenant logs into the solution, generally it will get the tenant ID as a response, as a part of the login response. So what the client side can do right now is to send this tenant ID with the request of the APIs that API Gateway wants to meter. So you can send it as a request header. And then API Gateway will pass the tenant ID to the Lambda authorizer. Lambda authorizer will simply visit our microservice and get the API key and present to the API Gateway. Now, API Gateway will know which API key that this request belongs to. And then it also knows which usage plan that API key belongs to as well. And the API and the usage plan will define the throttling values and the quota values. So API Gateway now can do the validation to see whether this particular tenant someone is getting throttled, or whether they're actually within the quotas that's been given by the admin. So if anything happens, or if the throttling happens or quotas are finished, it will be HTTP error request back to the client side, otherwise passed to the downstream microservices. So this is just the high-level architecture and how the components are working together in order to get this design pattern done using the AWS API Gateway.
Cool, nicely explained as well, Damika. So that's the architecture. Architectures are lovely, but we know that someone has to build that architecture. The next part is probably all about that. So Nick, probably jumping over to you now. Any demos and stuff we can share of how to actually build that out?
Yeah, so I've got a pep at live demo. So it's based on the blog post link that Derek shared earlier. So it's kind of built on top of that. So I'll demo it in a few different sections. So the first part I'm gonna do is essentially the live before tiering and throttling. So simple API, there's no tiering, no throttling, and kind of demonstrating that impact of noise neighbor. So for the demo, I am going to be just using Cloud9 ID on AWS. It just makes it much easier to share. So I will do a very basic load testing with Locust, which is Python load testing library. So I'm here showing 2 tenants, I'm kind of splitting the load between the 2. So let me just refresh this guy and say I'm gonna do. I've artificially lowered the limit of this particular API, so we can demonstrate a bit easier.
Yep.
So I'm
and
gonna
what we should do. Sorry, Nick. Before you begin, we should say, please, demo gods, be kind.
Yes. Yeah. So essentially here, what I'm saying is, up to 10, requests and, spawn 5 new requests or users at a time. So if I start, you will see, there's a 66% failure rate. So if I go into failure, you can see both tenant 1 and then tenant 2. Both of them are being super noisy and they're both getting 49, right? So this is kind of the behavior, like whatever the like the resource limit is for your SaaS service. Once it's saturated, and the auto scaling limits, the max limits that you have set, regardless of your architecture, this is the behavior you're going to see. And what I'm going to do now is use a Cloud Shell. Let me just copy what I prepared earlier. Call that API.
If anybody doesn't know what Cloud Shell is, you can run a terminal inside your browser that runs on AWS. It's very handy indeed.
Yeah, and very handy for demo.
Yes.
Yeah. So what I'm just going to do here is just use a simple code command. I'm demonstrating tenant 3. Let's say it's a new tenant that actually hasn't used, and as you can see from previous, there's still throttling happening. So when I do this, yeah, this tenant is also going to get 49 and getting too many requests and response back from the API. So this essentially demonstrates the problem. Even for new tenants you're onboarding, you've acquired all these customers, but from the day one, they may be experiencing like this degraded experience if there's a lot of load from other tenants.
Whoops, not a good experience at all for users. I'll just jump in and say, welcome people who have just joined. You've joined us halfway through another episode of Building SaaS on AWS. And today we're talking about noisy neighbors and their impact into your multi-tenant environment and how you can negate that impact by using throttling via API gateway. And Nick D'Amica is just taking us through the architecture and pattern that you can use to negate it. And Nick is now taking us through some demos. So back to you, Nick.
All right. So next thing is I will, show some concrete example of what D'Amica touched on in the architecture and the components we're going to use in API Gateway. So I've got this multi-tenant sample API, which is the code base from the blog post. So I'm just going to ignore this admin function. So in the repo from the blog, you do have this SaaS admin API, which allows the tenants to actually purchase new API keys. But we're just going to focus on the data API, which is a really simple Lambda function. Hopefully you can actually see this. Okay, I'm zoomed in. Maybe zoom out a little bit. So you can see for the GET request for API, which is the API one I'm going to be using to demo. So you can see that I've got custom authorization and API key is required. So if we dig into that, you can see for authorization, I am using this Lambda authorizer. And then, you also have option to use Cognito. And I've set this API key to be required. So that's how you sort of manage, what resources will be, requiring API keys and usage plans and how you're going to perform those authorizations. And let me show a few usage plans. So I've got 3 tier representing 2 requests per second in this case, and the bucket size is 5. So, if they've done 7 requests in per second, then that's it, right? The size of bucket is now exhausted, and you just get 2 tokens every second. And I've set the low quarter limit of 500 requests per day for 3 tier. Then I've got basic, which is slightly higher, 5 requests per second. 10 as the bucket size or the burst size, and then quarter, daily quarter, and then premium. I've just set it in for this demo, 80 requests per second, and 200,000 requests per day. And just what I draw your attention to down here is the usage plans associated with API stages. So with API stage, you can think of it as a deployed instance of your API. So it could be a production, non-production, or you may have different endpoints for different tenants. But in this case, everything's pulled. We have this one prod stage. So this usage plan is associated with this production stage of this API. Yeah, and then you can see number of API keys. To make it really easy, I've done one-to-one mapping. One tenant equals one API key. So for premium, I've got Unicorn, Sunicorn, and new Unicorn X. And then free tier, you can see some other tenants that are signed up for trial.
Yeah. What about if we wanted to use CDK to provision this sort of stuff, Nick? Would it be possible?
Yeah. So if I go back to Cloud9, so let me actually start this load testing. So all of the API gateway and usage plans you have seen here are built through CDK stack. So that's also linked in the blog post. So you can see I'm creating this REST API called multi-tenant sample API. And you can see there's other related resources being created. And you'll see that I've got two different authorizers. One backed by Cognito, used for the SaaS admin side. And I've got this Lambda authorizer that I'm using for this demo. So all of this, of course, you can build using CDK, and that's deployed into this AWS account for the demo.
I should have just been clear. CDK is how you define infrastructure is code as code. So rather than using YAML templates or JSON, you can actually write your infrastructure as code in the code of your choice, which is pretty cool. I've got a question from JW01. If you were to implement a per API quota, you'd have to handle a per API quota on your own. Is that a correct assumption?
Yeah, with the quotas, like a lot of customers who may start to implement, they may have just artificially high quota because, I will get to kind of making those data-driven decisions, but behaviors change. You may not know. You may not want to throttle your customers. You don't really know how to tier your customers, especially if you don't have historical data. And I do see a lot of customers starting with quite a high artificial limit to start with, and start to get those metrics and look at the tiering as a kind of phase 2.
Cool. And so you're definitely using API keys. Do customers actually pass those in with requests in their SaaS solutions?
So you can. I think that's sort of common thing that you have seen from many other SaaS platforms where you send in the API keys in the header along with your job tokens. So for this demo, I am using Lambda authorizer. So if I just go into this authorizer here, so you can see which Lambda function I'm using for the authorization of that. And I'm saying I'm going to get the authorization source from as the header value from authorization, and I'm going to cache this for 10 minutes. And let me go into this Lambda function. So this represents getting the tenant ID, in this case, the SaaS identity of the request from the header. Typically, in production setting, of course, this is going to be typically job token with signature that you can validate. But for this demo, I am actually just sending through plain text tenant ID in that header. So I don't do validation, and you can see here that I'm just doing a lookup against DynamoDB table representing that tenant microservice. So based on the tenant ID, does this tenant have API key associated with it or assigned? And that gets returned. So you can see if the tenant ID doesn't exist, or they don't have API key assigned, what I do is actually I just simply deny everything. If they do, they are allowed to access any APIs. So like really simplistic demo. So it's like allow all or deny all.
And but that it's we're proving a point is the actual underlying reason why we're showing this, Nick. So
yeah,
sometimes simple is good.
Yeah. And let me just like quickly see if I can bring in some value of what that might look like. So the Lambda authorizer essentially returns a policy document. So this is what it will look like if they are allowed. So, for basically saying for this API stage, I happen to be prod, all resources and all methods are allowed. And this particular value here, usage identifier key. So that's the actual API key that's associated with those usage plans that we talked about earlier. So from your tenants, they may not need to change anything if you're sort of going with this Lambda authorizer route. So they continue to send in the tenant identifier or SaaS identifier in the headers or job tokens, any other method that you have, and the Lambda authorizer essentially is doing a lookup and getting the API key to use, and that's how API gateway would track the usage.
Well, what about the results from our earlier test with Lucas?
Yeah, so let me actually run the other test. I should have actually started this earlier. So now this is testing the other multi-tenant API. So
we're live.
I have 100. So for demo purpose, you will see I've got basic tier, free tier, and premium tiers. And at the moment, everyone is quite happy. I'll let this run for a little bit, and you'll start to see some tenants are being throttled, but not the others. So essentially showing the usage plan in action.
Nice. So how do you then check? So let's let that run. But how do you then how do you verify, Nick, that you have your tiering right? Because you may have made a mistake. We all make mistakes. How do you verify that everything's working correctly?
Yeah. So over here, I'll just go through this bit. So you can see, the basic tier tenant and free tier tenants, they're starting to get 429. Please ignore the 500 error. This is live demo. So the important thing is that 429 for some of the tiers. So let me just leave that running in the background. So yeah, how do you know that if you got it right? Data-driven decisions. So I think let me start with dashboard. In this case, just demoing with a quick site. So you can look at usage of your platform by tier. So in this case, I've generated some artificial load over last week. So you can see 88% of the consumption or number of requests for your platform is done by premium tier. This may or may not match what you originally had thought when you introduced the tiering. And you can see, like 10% is consumed by basic tier customers. So, one dimension is like what percentage of, your resources, usually related to cost as well, is, broken up by different tiers, segments. And then you can also look at things like top tenants. Very obvious naming, but Unicorn is using the most number of resources on your SaaS platform, followed by Sunicorn, and then some of the smaller business names like Books and Microbrewery, and then trial users, right? So this is kind of ranked by tenants.
Yep. JW1 asked the question. I was actually thinking this. The lovely dashboard that you've created, Nick, is that shared anywhere? He asked as a part of the stack, but I doubt it. It's anywhere else.
Yeah, it's actually not in the blog post, but yeah, we can share. I'll actually talk a little bit about architecture to get to this point. But just going through to other two visuals on this dashboard. So other important thing to really look at is which tenants are being throttled, right? So over past month, or this month of September, you can see there are 3 tenants that have experienced some level of throttling. And you can see this books user who is actually on basic tier. They are being throttled a lot. So this might represent either misuse of the system by this tenant, or maybe they are actually signed up to wrong tenant, wrong tier, right? So this is kind of starting point for having one conversation with your customer. Are they actually utilizing your system? Do you understand their needs? And have those conversations, or they could also tell you that your tiering is completely out of the whack and it actually doesn't match real world usage. So having this data points is really important.
Cool, nice, beautiful dashboard.
Yeah, and then usage by tenant, so you can see the basic plan. The books user in particular is using a lot more than the other basic plans. So there is some gap in there to have those conversations.
Cool. Awesome. The demo gods were reasonably kind. Is there anything else you want to share before I remove your screen, Nick? Have we missed anything?
Talk about just like how we get to that particular dashboard. So API gateway, like there's access log that's available and it's built through that. So what I've done is actually create this Kinesis Firehose with the transformation using another Lambda function. So this Lambda function essentially does a lookup to get, enrich that access log with the usage plan, names, details, API keys, things like that. Dump that all into S3 bucket. I use Glue to crawl that data set, and essentially, using Athena with QuickSight to get to the visualization. So I, have this running, every hour, and this creates that data-driven decision for your SaaS platform.
Lovely. And is that? Do we share that anywhere? Do we have the resources so somebody could build that if they wanted?
It's not in the particular repo yet, but yes, there will be resources.
Yeah, because I think that's awesome. I think that should be shared. That's very cool.
Probably next blog post for you, Nick.
There you go, Nick.
Yeah. I might have to
if you'd like Nick to write a part 3 of the blog post, then put some pressure on him in the chat right now. Thanks, Nick. Let's move back to Mika and ask. So, is there anything from an architectural point of view that you need to remember and use design pattern when you're trying to scale these SaaS solutions?
Yeah. So when you say scaling, that means you go live and we kind of scale your business into probably multiple regions, and you continuously having different addition to the tenant, to new tenants to the solution, etc. So when you grow as a SaaS solution, right? So when you have increasing number of tenants going forward, one of the things to think about is the kind of the limitations of the architecture, and then some of the quota limits in the services that you are using as well. Now, in this particular design pattern that we're introducing, the API throttling, so most of the numbers are actually flexible, that you can increase in terms of the throttling and in the usage plan. You can only create 10,000 API keys per account in the API gateway per region. So which means that if you keep on allocating one API key per tenant, and if you're expecting more than 10,000 tenants long term, down the line, you're going to run out of the API keys to assign to new tenants coming after that. So what you need to do is to kind of tweak your architecture in a way that you support a a mechanism so that you can save some number of API keys to be reused later on. So the way to go ahead is to share the API keys across multiple tenants. So, but how can you share that? What is the logic behind that? How do you select the tenants or the set of tenants to share the API keys, right? So the best way to go ahead is to follow your tiering strategy. So let me get my final slide up and running here just to get some perspective here. Yeah. So
There you go.
yeah. So basically, in my example, like I know that the platinum tier customers are the most important customers that adds the biggest business value to me. So what I'm going to do is I'm still going to have the same
We just lost this
just lost it.
slides.
All
There we
right.
go.
Okay,
Yeah.
there you go. So I'm going to still have the dedicated API key per tenant for the premium customers in the platinum tier. And what I'm going to do is I'm going to share the fixed number of API keys for other two tiers. So in the tier in the second tier, I'm going to throw just a couple of API keys, and then all the, let's say, 20 tenants in that particular tier 2 will be sharing these two API keys only. But programmatically, I want to make sure that the distribution of these two keys would be even across the 20 tenants to get the maximum capacity of the throttling and the quotas. The tier 1 is a free tier. I would kind of expose that to kind of anyone to try out some of the features that I would like them to try out before signing up really. So it'll be just one API key for all the tenants in the tier 1 in this case. Now, how do you select how many number of API keys to go with the tier 1 and tier 2? It's really based on, again, historical data. And if you don't have anything like that, just go with some numbers and then revisit down the line. So idea here is you're going to save the API keys from the tier 1 and tier 2 and then kind of allocate them and then save them to allocate for the platinum tier customers when you get them down the line. So this way you can actually use the same solution for larger number of tenants going forward.
Yeah, it's a good question from Barfight. So how often, and you may have come across this in reality, how often is a SaaS going to have greater than 10K clients, or do you find people assigning more than one key per tenant?
Yeah, so that's a great question. So generally we don't get that much of use cases like that based on my experience, but once in a while you find the customers with the use cases like that. The key here is you don't generally get that number of tenants hit pretty soon. It's a long-term decision. So you always need to ask yourself when you're building a SaaS solution, what is the configuration? How many number of tenants that you expect long-term? So if you have a potential to hit more than 10,000 clients, probably you can have a shared infrastructure or shared API key for a couple of tiers would make sense. Otherwise, you can always go with the API key per tenant, and then as and when based on the number of tenants, you can do the alteration going forward as well.
Yeah, I think also JW1 had a good point as well. Multiple client apps may also get you into that situation potentially.
So yes, but it really depends on how many tenants you have, because if you look at from API keys standpoint, in the first model that we went through, which is called silo model, we are going to have one API key would represent one tenant itself, how many client apps that they would have. So from the API gateway standpoint, what API gateway looks for is how much of APIs are coming from one tenant. How many clients have, how many mobile apps that they have, doesn't matter, just how many number of tenants. So in that case, it'll be directly proportional to the number of tenants in terms of the use case.
Gotcha. Cool. So where are we at to now? So that's well explained again, Damika. Let's I've got some, if you've got some other questions for Damika and Nick, just push them in the chat. I've got some that I want to ask about. Usually when you talk about noisy neighbors, or what I call naughty neighbors, usually rate limiting is always the right answer. Is that always the right answer?
Let me take that one. So I think first place to really start is really think about your tenant isolation model. So is it going to be silo, pull, or bridge, which could be a bit of a mix? Many of SaaS providers end up there, right? So with commonly, sometimes with large enterprise customers, you may even end up with account level or AWS account level isolation, where you have really concrete boundaries of how you isolate tenants from affecting others. But when you get into SaaS, it's a growth and scale model. That's where you get those efficiencies and economies of scale. So often, there will be some services, or you will end up with some services that are pull model, and the exceptions being, some industries based on regulatory or compliance. We love those. You may still, end up with multiple accounts or account level isolation. So, using it, doing rate limiting and quarters on API, what we often, see it as a front door to your SaaS application. It's quite an easy way to implement this mechanism because it's, architecture agnostic. However, your application is, architected monolith to microservice, serverless.
Oh, we lost Nick. We've lost Nick. While Nick's getting back to us, there's actually we've got a question from Umon, and I think Umon may have jumped in late, but it's sorry if I've already answered, but maybe it's worth reiterating. If multiple tenants are sharing the same API key, how do you stop one tenant from eating another tenant's quota? You can answer that, Davika.
Yeah, so when you're sharing an API key across multiple tenants, you are basically sharing the overall quota across the tenants as well. So there is no real way in this design to kind of differentiate, what is the quota definition for tier tenant 1 and tenant 2 when they're actually in the same tier sharing one API key, for example. So in that case, what you can do is, just based on the historical metrics, keep on adjusting the quota values. If you, for example, let's say the basic tier is actually using 2 API keys in my example, so in that case, you can, if you see that more and more customers getting throttled because of the quotas is finished, or the throttling values are actually not enough, you can continuously validate them and kind of refine them. That's the way to move forward when you are sharing the API keys across multiple tenants.
Oh, nice. And I think Nick has been back now from his throttling incident. As Gunnar pointed out, yes, he'd been throttled. We don't know if it was a 429 or a 504, so we'll still try and work that out and get back to you on that one. The next question I've got, Nick, and we've got probably about 7 minutes left, is I'm going to ask you this one, Nick. So how would, from a client side, how do you sort of, any techniques or patterns you can implement from a client to try and handle throttling a bit more gracefully?
Yeah, I think, we're so used to actually having APIs, think about AWS services, right? So, when you are providing client app or SDK for your platform, it should always implement, some logic that are specific to HTTP 429 response. In this case, so the stream, they just dropped me and then you moved on. That's perfect. So, and what that means is almost always, that means some form of retry, try again later. That will typically, solve these challenges. And there's number of approaches, right? So you can start with simple retry, just with maximum retry limit and some kind of interval between retries, and then you can start to look at exponential backoff. So you start to increase the the wait time between the retries, but of course, when you do that, it does add up really quickly. So you probably won't have a max delay and max retry attempts to do that. And then other is jitter. So once you hit these limits, you don't want to be retrying every second. So it just introduced a little bit of randomness between retries so that they don't all like come at the same time. And many use combination of 3 or row 3. AWS SDK is a good example. It implements these retry logics.
Yep, for sure. And then if you want to get really fancy, you can implement a circuit breaker. There's a question from JW1. It's a little bit off topic, but I think it's an interesting discussion in itself. So would you recommend, we've talked about keys quite a bit, but when we move on to authorization, would you recommend using API keys in this sort of architecture?
I think we both have really strong opinions. Yeah.
I have a very strong opinion here.
Yeah. I would not, from architecture standpoint, the reason for that is API keys are not encrypted like GW tokens, so anyone can actually see the communication and what's inside, and can steal it and do a lot of other things. And also, it doesn't have it doesn't get expired. You don't have a time to live value for that like a GW token. So we kind of use, especially when your solution is a multi-tenant SaaS, we use API keys strictly for metering purposes. And not for any authentication or authorization purposes. Because of that, it's not a, I would say, it's not a standard security best practice on cloud.
I agree 100%.
Same. You should always have encrypted tokens as authorizers, not strings. Awesome. I think we've got time for one more, probably. So Damika, I'll probably ask the last question to you. So what about monitoring? We've seen Nick's lovely dashboard. Can it let you know when tenants' traffic is throttled? So can it actually, give you real time updates on when throttling is happening?
Yeah, absolutely. So you can actually keep on monitoring the, for example, API gateway logs, or maybe configure the CloudWatch to do that for you, to get the real time or near real time kind of triggers when the throttling happens. And then you can do a lot of things. You can even notify the actual tenants based on the frequency of the throttling happens. And one of the use cases that Nick and myself have been discussing, that we see with most of the customers and partners implemented this design pattern, is that when you have the throttling happens, you kind of detect that, and you kind of have a look of the history and see how many number of times this particular tenant has got throttled before. If there is a continuous pattern that we see, we can have an automation in place to get a sales and marketing campaign up and running, and then send a recommendation to these tenants to kind of upgrade their tier to the next level. Because continuous throttling means their business is getting impacted, and probably they don't know. What happens is, when you have from the customer standpoint, I use your SaaS solution, and my company grows in terms of number of users. So, but I still work with the original configuration that I sign up for in my tier, even though I have large number of users right now. So these things can be automated. These notifications and the recommendations can be automated using the same method, so that the upgrading to the next tiers can be done seamlessly. So things like that are possible, and certainly we can have the throttling detected real time as well.
Awesome, great, well answered again. So we're coming to the end of the show. This Building SaaS on AWS show, this goes out at this particular time frame. Just answering Barfights question. This show goes out same time, same place on Twitch/AWS every 2 weeks at this time frame. We also have another version of this show that's more EMEA, so a European time zone friendly, and Gunnar is the host for that, and Gunnar's on as well. I see him in the chat. So I have no idea when his show is on in time zone, but we have 2 versions of the Building SaaS on AWS. Also, we have got lots of past episodes. So if you like the show, you like the content, we have past episodes on the Twitch/AWS. Follow us all on socials and keep up to date with all of the latest episodes, where the past episodes are, and stuff like that. So I hope you enjoyed the show. Damika and Nick, thanks very much. I hope you enjoyed being guests on the show. you survived.
Well, thanks for having us.
Thank you.
And yeah,
Thank you, Derek. Thank you so
Yep.
much. It was amazing.
Excellent, excellent. Well, he's still alive. The demos worked. The questions were answered beautifully. And thanks again for coming on. So that's it from us for another week of Building SaaS on AWS. As I say, in 2 weeks, we'll be back. Same time, same place. Until then, bye.
Bye-bye, everybody.
bye.